Hello, welcome everyone to this webinar hosted by UReason. Today I'm your presenter. My name is Jules Oepmans. I have a background in AI starting in the 90s and have been involved in many times in the past 25 years in prognostic and predictive programs to ensure asset integrity for critical assets and critical processes. If you want to reach out to me after the webinar, here are my contact details. Please don't hesitate to contact me with any questions or remarks or comments that you have. Today we're going to look at how you can ensure asset integrity given the changed environment that we are in. In the distribution and transmission systems, there's a rapid change of demand and supply profiles, and this has a lot of consequences on how you best manage the assets that provide a critical role in the distribution and transmission networks. The growing supply of energy from alternative sources in both Europe and the US is creating a new balance for how assets are being used and are being managed from a maintenance perspective. This becomes quite clear, quite apparent if we look at the energy production in the Netherlands and Germany, just as two examples. In April, a few weeks ago, the supply of solar and wind has a great influence, and based on the load of the network, which is also supported by gas, coal, and other traditional resources, distribution and transmission owners are running their assets in a very different way of how they used to run it in the past few decades. This shift in balance is driving distribution and transmission owners in different ways. There's a pressure to increase the profits, but at the same time, due to the fluctuations in demand and supply, we see that asset owners need to be more agile in the maintenance and servicing of their assets. Also, there is much more tighter regulation and an increased compliance risk that drives a lot of asset improvement processes. And the fact that our assets in the distribution and transmission networks are aging is not helping a lot. There's also an increased focus on asset reliability, where asset managers need to balance in different time zones and different time horizons, taking into account the aging infrastructure. Many assets in our distribution networks are decades old, but also the supply reliability that is influenced by variations in the demand and supply, and the power quality, which is influenced by, for example, solar and heat pumps. This is a balancing act where multiple time horizons need to be taken into account, balancing the assets that we have and the supply reliability that we need to provide to our customers. This variability in how we use the assets reflects in how assets wear and break down. This study that is shown on the screen, which was performed by Allianz, shows that because of the Energiewende, the change in solar and wind energy that was introduced in Germany, the stress on assets like steam turbines that were normally turned on and left running and operated in a very narrow window are now operated in a very variable way to cope with the fluctuations that are introduced by solar and wind, causing very different mean time to failure rates as originally engineered or thought out. As we more variably run and switch our assets, we also need to take into account that the age of many assets in the distribution and transmission networks is high. And as a result of this, the failure rates of these assets are also increasing quite rapidly, as we see here in this picture, where the transformer failure rate function is set out against the age of the transformers. Many of the failures in the network are actually detectable. Not all of them are preventable, such as lightning strikes, for example. But many of the failures that we see in distribution and transmission assets are actually detectable using data that is available to you as an asset owner of your devices. So we see a drive for change, which is fueled by the diversity in the demand and supply, as well as the asset age. And the business drivers for change are obviously lowering maintenance costs and operational costs. But at the same time, we want to improve the availability and uptime and extending the remaining useful lifetime of our assets. And these are sometimes contradicting goals that cannot always be achieved. So let me ask a question to you as a public, which will show up as a poll to understand what your current maintenance strategy is with respect to your critical assets in distribution and transmission networks, or if you're an OEM, the critical assets that you provide to this industry. So on the screen, you can answer what your current maintenance strategy is for your critical assets in distribution and transmission networks. So do you have a reactive, a preventive, a condition-based, or a predictive maintenance strategy? And the answers are coming in. I'll just wait a few seconds for more answers to arrive. So the majority of the respondents have actually indicated that they have a reactive maintenance strategy, i.e. wait until the assets break down and then take action. On the second place is condition-based, so using data available in assets or using inspection data that is collected, providing what best condition is of the assets at a given time. And none of you is doing a predictive maintenance strategy at the moment. Thanks for your answers. I think I advanced. Yeah, sorry about that. My slide is stuck. So a solution towards using more of the data that is available in your assets allows you to run a more data-driven maintenance approach. So allows you to switch to condition-based or predictive maintenance. This allows you to switch from preventive and reactive maintenance programs to a more data-driven approach where the data from the assets is used to continuously determine the functional degradations ahead of time. So continuously determine the potential failure points to prevent these failures from happening. So using data, try to ascertain where your asset currently is on this PF curve to prevent this failure from happening, such that you can plan, identify, prioritize, and plan a correct PF interval. So UReason uses a structured approach that achieves this. We select the assets based on the criticality of the asset. For these assets, in step 2, we collect data from multiple sources. I'll come back to that in a later slide. And on the basis of data, we determine if we can see upcoming degradations and failures early. So on the basis of data, we try to construct these PF curves where we classify the potential failures and see if using the data, there's enough or sufficient time for maintenance activities to be planned. Let me explain this in a little bit more detail in the following slides. So for asset selection, step number 1, let's say we select a transformer. I think most of you are quite aware or quite accustomed to transformers, either in distribution or transmission networks. So for the selected asset, the transformer in this case, we collect the FMEA, the failure mode and effect analysis. or FMECA, failure mode effect and criticality analysis. And this allows us to focus on the failure modes that have the highest impact or the highest risk priority number, i.e. the failures that actually matter. For the selected assets and the functional degradations and failure modes, we map the different degradations and functional failures to the frequency and the expected downtime. This is shown here in the graph. On the y-axis, the failure frequency from very rare in the bottom to very frequent at the top, and the downtime expressed in hours, which you can translate to risk or to costs from low, 0, 10 to high downtime. The area that you need to focus on if you want to move to a condition-based or predictive maintenance program is quadrant number 3 and quadrant number 4, where condition-based monitoring and predictive maintenance programs driven by data can help you make a significant change on how you manage the maintenance activities for your assets. Using the ISO 13374 as a guidance, we start to collect data for the different assets that have been selected or the different process. And where necessary, manipulate the data and provide an indication of asset health for the selected assets. The ISO standard is quite a nice guidance in structuring this program in a very nice way. So data is collected from multiple sources. Process or asset data is collected from the data historians by IP21, Exaquantum, depending on what automation system you have. And maintenance data is collected from your maintenance management systems, Maximo, SAP, Ultimo, and the likes. And the maintenance data actually contains a lot of failure data or pre-failure data that is quite helpful in setting up models that can predict, can classify an upset and oncoming of a failure. The last source of data is failure data. This is a source that varies per company. CMMS data and process data from your process historians is normally quite easily accessible, but in failure data, we see that there are no or few standard ways in which companies store this degradation and failure data. So that is sometimes a challenge. But as I indicated, it's also sometimes hidden in your maintenance management systems. So based on the data collection, we map the FMEA or the FMECA to the data that is available to determine if for the listed failure modes, the failure modes that are of interest, we would be able to determine if these can be detected early based on the measures and obtained data. So here, for example, we see different failure modes for a transformer. Physical chemistry of the windings is deteriorating, which could be caused by excessive moisture. So is there, for example, data available from a oil sensor that measures particles? If it is available in a historian, that is a very good source to base a condition and or predictive maintenance program on. And the same goes for these other failure modes. For example, mechanical failure modes of loose clamping can maybe also be detected by looking at the capacitance change and leakage reactions in your historical data and potentially failures logged in the maintenance management system. So let me ask you a question about data availability. It's a multiple choice, so you can provide multiple inputs in this question. So what data do you have available for starting a condition-based or predictive maintenance program on your current assets? So do you have real-time data available? Or maybe you have real-time data and historical data available from an historian, maintenance data, and perhaps also data from OEE databases. You can provide multiple choices here. So I'll wait some time for the responses to get in. And they're coming in. So leading from the start, when people started answering the questions, is data from historian databases by IP21, Exaquantum, SQL Server, etc. And that's followed actually by maintenance data. So actually that is a very good combination if you have both historical data, depending on, of course, what frequency you store it at, and the maintenance data. These are sources that help you quite well in setting up a condition-based and predictive maintenance program. So reflecting back to the ISO standard, the 13374, you can run a condition-based maintenance program if the historical data and the maintenance data, the data containing the degradations, have sufficient or provide sufficient detail to train models that provide you with an accuracy below, for example, 80%. This is really something that is company dependent. So if you set out to run a predictive maintenance program, but you have insufficient functional degradation and failure data, then it's best to stay with a condition-based maintenance program. However, if you do have sufficient data to train models with a well enough or high enough accuracy, then the next logical step or the best logical step is actually to combine condition-based and predictive maintenance programs on your assets. So in modeling the different algorithms, you have to find the best fitting solution for actually two areas. You have to be able to classify the failure, i.e. classify the failure that you want to predict. So that could be a degradation of the windings of a transformer, for example. And you have to be able to predict the time at which this happens. So there are different types of machine learning models to do both of these. So for classification, you can use neural networks, support vector machines, and a few other types of algorithms. For determining the time interval, so that is the PF interval shown here on the curve, you typically use regression models. Both, i.e. the combination of these, is required because you want to know what is going to happen, what is likely going to happen, and when it is going to happen. So when you have enough data and when you have enough data to train a model that with a high accuracy can provide a classification and the timing of an event, you can go ahead and deploy these. Now, UReason's APM Studio provides a capability to import PMML files that is shown here in the middle of the slide. And PMML stands for Predictive Model Markup Language. This allows you to go from your analysis environment, for example, in R, Python, SPSS, or any other environment that is PMML compliant, to an environment in which you can, in real time, on the basis of streaming data, execute your machine learning models. And APM Studio allows you to quite easily embed PMML models, combine this with deterministic and probabilistic models to create solutions that you can deploy either near the asset, even in the asset, or at the edge level, or on-premise in level 2 or level 3 automation systems, or even in the cloud. Now, the deployment results, for example, in new work orders that notify maintenance planners of upcoming maintenance activities required for your assets, indicated or based on the data and the outputs of the model. And this is a new work stream that is introduced for your maintenance planners to take into account a predictive work stream, indicating that assets, based on the data, based on the models that have been trained, require some maintenance activities. Next to deployment towards a maintenance management system, we can also provide notifications that go out to your field personnel that is servicing, for example, the asset in question or the assets in question, providing support via automated cause consequence text, which help them in troubleshooting what is actually happening at the asset. And we can do this using Slack or using Skype. Of course, with APM Studio, you can also create dashboards that can be embedded into your existing systems. And all of these dashboards are web-based, so they're quite easily integrated in your current programs and your current dashboard capabilities that you may already have for your assets and for your field engineers. So the APM software suite by UReason allows you to go from data to solutions, from using historical data to set up, test, and validate cause consequence models, predictive models, and see how these provide decision support to your field engineers. And you can deploy, as I mentioned earlier, to devices either embedded on edge, on-premise, or in cloud. So there's many capabilities in APM Studio that allow you to monitor your assets and optimize your maintenance processes to prevent unplanned downtime and reduce maintenance activities. So with APM Studio, you can provide monitoring of assets. And if you have sufficient failure data and functional degradation data, you can start a CBM program, condition-based monitoring program, and extend this to a predictive maintenance program, and even prescriptive if you want to inform field personnel actively in the field and assist them with troubleshooting. So let me ask you, the audience, another question: what the drivers for you are in actually looking at condition-based monitoring and predictive maintenance programs. So there will be a set of choices again highlighted on your screen. What the drivers are for you, if it's lower maintenance cost, unplanned downtime prevention, lower energy cost, or if there are other reasons. So I'll wait for the answers to come in. And the answers are coming in. So most, again, from the start, it was the highest response. Most of you have a driver to look at condition-based and predictive maintenance program to prevent unplanned downtime, i.e. to prevent the asset from failing and not being able to provide its function anymore, which is kind of what I was expecting. That's good. So APM Studio is quite unique in the sense that it allows you to deploy solutions at different levels, from asset to edge to on-premise and cloud. But you can also connect it to multiple data sources, being real-time or batch or combinations of those. Especially maintenance data is very often collected in a batch mode. Plus the capabilities that within APM Studio, you can combine fault models and probabilistic risk models in combination to improve asset insights and asset integrity. We work, we get the question quite a lot. We work for both asset owners and OEMs in industry. Here's a list of some of our customers. The reason why we also work a lot with OEMs is because This market is providing additional capabilities to its asset owners to better gauge, better understand what the integrity of the assets are. And this is a growing market for us. So let me ask you another set of questions on what your implementation challenges are in going towards a condition-based or predictive maintenance program. Are they in the silos that you need to integrate from OT and IT? So OT systems monitoring your assets and IT systems providing, for example, maintenance management systems, or is it in the lack of data analytics capability, or maybe it's in the lack of relevant data that is available, or maybe there's no commitment from higher management to invest in this, or there's a lack of business case. So I'll wait again for the answers to come in. So there are two leaders. The first leader is the integration of OT and IT. So that's one of the challenges that you're confronted with. It is also something that we experience a lot when we work with asset owners, especially with asset owners. The silos between the different systems in the OT environment and the IT environment sometimes make it difficult. Sometimes there are big barriers to get data from multiple sources. On the second spot was actually the lack of relevant data, i.e., there is no relevant data available for the assets. This is sometimes a challenge that we encounter on working with prospects. That we typically create a minimal viable product for our customers, where we address the OT IT bridging, so to say, and the search for relevant data. Very often we find that there is a lot of relevant data, but very often it's not available to the people in the maintenance domain, but only to the people, for example, in operations. So this is one of the areas. Actually, the responses are quite similar to what we experience in the field as well. One of the areas where we focus on investigating what data is available, what data can be turned into value for condition-based and predictive maintenance applications. So let me look at the chat to see if there's any questions. Let me just check with the moderators. Okay, there is a couple of questions. Thanks, Simas, for collecting these. So one of the questions from the audience is, can I start a predictive maintenance project without maintenance management data? You can. The maintenance data is very often used to provide insights into functional failures and functional degradations that happened on the assets. However, if you have very low quality maintenance data in your maintenance management system, or if you basically lack, root causes because the engineers don't have time or don't have the discipline to enter it, or a combination of both, then you can start a predictive maintenance program without CMMS data. What we typically do is then, on the basis of efficiency of the specific asset and the specific functions in the asset, we start identifying different labels that allow you to plot functional degradations on the PF curve, and we allow you to label the data with the functional degradation such that you can train and validate models on this. It is a good approach. So it's something that that we come across quite a lot. Another question is, do I need high frequency data from my assets because I only have second data from my Pi historian? Well, this really depends on the type of failure mode that you want to classify, or the type of functional degradation that you want to classify. So let's say you are looking at the degradation of the windings in a transformer. Then the oil analysis samples, if you have a low-end oil analysis sensor in your transformer, so not a DGA one, but a lower-end one, they typically provide data updates every 5 to 10 seconds. And that's sufficient data to see an oncoming trend of particles in your oil, sufficient to run a condition-based or predictive maintenance program on. However, if you have, especially when it comes to mechanically rotating elements, so for example in power generations on steam turbines, then it's sometimes necessary to have access to high frequency data, high frequency vibration data, for example. So it really depends. The need for high frequency data really depends on the type of failure mode that you're interested in to classify in your data. There is another question here, and it is, how can I best capture the data in my maintenance management system? Well, so as I indicated earlier, sometimes the data that is available in a maintenance management system is of low quality because of a variety of reasons. And one of the very good ways to structure the data inputs into a maintenance management system is to follow the ISO 12224. It's a standard that provides you with structure and predefined texts of entry that you can provide to your field engineers, such that the data entry, i.e. the data going into your maintenance management system, Maximo, Ultimo, SAP or alike, is much more uniform and much more usable. So there's light at the end of the tunnel, I would say, with respect to using data from maintenance management systems and increasing the quality in those sources. Oh, here's another question. There's just quite a few questions, so keep them coming. I'll try to answer as many as possible. How could predictive maintenance help my company to get ahead in the energy sector? Well, predictive maintenance allows you to lower maintenance cost and optimize maintenance schedules. So instead of doing a lot of preventive maintenance rounds, you can actually deal with assets as and when they require attention. And as such, you will have a higher level of asset integrity for the assets involved on which you run a predictive maintenance program. I'm not sure how to answer the getting ahead in the energy sector, because that's a quite a broad question. But it will certainly help you to reduce the costs that you have, maintenance costs, and the troubles or the headaches that you have with respect to how well or good certain assets are performing or underperforming. So I'm scrolling down here in the list. There's a question, what would be the first steps, the first best steps that companies need to make to move towards predictive maintenance? Good question. I think I can answer this from multiple directions. So One of the first steps to take moving towards predictive maintenance is to ascertain if the company, if data, the data that your company stores, that your company has available on the assets, is of a good enough quality, i.e., you have sufficient data to train and validate models that provide you with a high accuracy. So earlier on in the slides, I mentioned that a condition-based or predictive maintenance program makes sense if the accuracy of predictions is 80% or above. This means that 2 out of 10 predictions are actually off, or actually false. And this will improve over time as the quality of your data, etc., improves. But if you have too many false positives early on in the project, it is very often not motivating for the people that are involved in predictive maintenance programs to continue with it. So the first step the company needs to take is to make sure that the data quality is at a high level. And data quality of the quality of data stored in data historians is very often of a high level, because reporting systems and other business processes rely on the quality of that data. But especially on the maintenance management system side, so the CMMS systems, their quality of data could be improved. So these are the first steps to focus on data quality. And what is also important, a very good step next to data quality, is to make predictive maintenance a program with a champion, and to explain to people that are involved in operations but also in maintenance what a predictive maintenance program can bring to the company, because it's quite a change if you're currently doing preventive or reactive maintenance and you're moving towards a predictive maintenance program. It's quite a big step. If you're already doing condition monitoring and you're moving from condition monitoring to predictive maintenance, it's a smaller step. But especially if you go from preventive reactive to predictive, taking the organization along, helping and guiding the organization along is a very sensible thing, very good sensible thing to do at first. Here's a question. How can I pinpoint if predictive maintenance is for my company, or perhaps how can I pinpoint if predictive maintenance is for my company good, I think, or perhaps I'm better off with another maintenance strategy? Yeah, so this is about the business case of rolling out a predictive maintenance program at your company. So how can you pinpoint, how can you determine if it's a viable solution for the company that you're at? So um, earlier on, I explained that we, on the basis of data that is available, or a need to go towards a predictive or prescriptive program, we work with the customers, asset owners, and OEMs to do a minimal viable product. Sometimes prior to the MVP stage, we have a business case stage in which we analyze based on the maintenance data, so purely based on the maintenance data, if a changeover from preventive reactive maintenance to condition-based or predictive maintenance provides a positive business case, i.e., what are the investments and what are the expected results, in the next months and the next years. So for this, doing a business planning scenarios analysis is one of the very good ways to introduce a predictive maintenance program, or the justification for a predictive maintenance program in your company. I have a question here. How could UReason's APM Studio integrate with other platforms that my organization uses? So APM Studio has a lot of capabilities inside, but it also provides open interfaces. So if you, for example, need to interface to a CMMS system, Maximo or Ultimo or SAP or any of the others, we provide REST-based APIs and REST-based interfaces to integrate with those systems. If you let's say, need to tap into historical data from a PI database or IP21 or any other data historian, those data historians nowadays, luckily, have open query interfaces where, using SQL and tailing those historical databases is quite easy to set up and quite easy to use. So there's not a lot of limitations, or no limitations, I should say, in integrating APM Studio with other platforms. We also have a few customers that have IoT, or sometimes they're called IIoT platforms, in which we integrate, and there it's a variety of different interfaces, REST-based, SOAP sometimes, but a combination of interfaces to integrate into IIoT platforms running in the cloud using microservices and the likes. Okay, if there's any other questions, please let me know. Oh, I'm sorry, I needed to scroll down. Okay, there's a question here. Have you been working with digital twins? Yeah, so there's actually one of the companies that is mentioned here on the slide, UReason and Orano, that's in the nuclear side of things, so not on the renewables, but the nuclear side of things. We have provided digital twins, digital control twins, and digital twins to provide um, um, simulation capabilities to see where a specific asset or a specific process actually ends or will end. In the area of digital twins, we're also working with the Dutch government to set up an innovative program to use our current technology stack within APM Studio to see and to determine how control of assets and the frequency of the control of assets, and sometimes the wrong control of assets, actually influences the degradation functions of the asset. So we have been working with digital twins developed internally for specific assets and specific processes, not with other companies. Let me just see if I'm just scrolling down. Bear with me a second. And thanks, Arthur, for asking if there's any other questions. Well, if you have more questions, feel free to contact me on my email address with any questions or comments. And I would like to thank you for joining this webinar, providing the questions and the comments in public and in private chat. And I hope that you have learned certain items from this webinar, and love to see you again when this entire COVID thing is gone. Thank you a lot for attending. And the slides will be forwarded to all the attendees as a PDF. Thank you.